The school year is coming to an end, and you have the following test scores in your math class: a 73, an 88, a 90, another 90, and a 92. There's one test left, which you studied really hard for to help bring up your grade, and you got a 105. Your teacher counts all 6 tests equally to determine your final grade. An average test score of 90 or above will get you an A. Unfortunately, your teacher does not round up, so even an 89.9 means you'll get a B. The question is, did you get an A for the year after that amazing performance on the final test? We're about to find out using a cool trick for calculating averages called the over-under method. So the way this method works is we first choose what we call a pivot number. This is sort of like a guess for your average, but it can really be any number. A good pivot number is one that most of your values are close to. So in this case, we'll make our pivot number 90. Next, we'll start with our first test score, which was a 73. And we'll see how much it's over or under 90. We count overs as positive, and we count unders as negative. Since 73 is 17 under 90, we record that as negative 17. Our running total, which is just the cumulative sum of overs and unders, is currently negative 17. The next score was an 88, which is 2 under. Our running total is negative 19. Now come the two 90s. Since they are equal to our pivot number, we don't have to record anything, and our running total stays the same at negative 19. 92 is next, which is 2 over, so that gets recorded in the overs. Our running total has increased by 2, so now we're at negative 17. Finally, that whopping 105. It's 15 over 90, so we record the 15 in the overs, bringing our final running total to negative 2. Now we're ready to calculate our average. All we do is take our pivot number and then add to our pivot number the final running total divided by the number of test scores. In this case, our pivot number was 90, our final running total was negative 2, and we had 6 test scores. That comes out to a 90 minus 1/3, which means we're going to fall a little short of that A. The final average is 89.6 repeating. We might not have gotten the A, but we did learn a neat way to do averages. With practice, you can easily do this mentally without the use of a calculator. The trick can come in handy, especially on exams that require you to calculate an average but don't allow a calculator. So, now you know how the over-under method for averages works, but there's one more thing we need to do. Are you ready? We need to understand why this works. As you recall, the traditional formula for an average looks like this. X bar is the average, n is the number of items we're averaging, and the sigma x sub I from 1 to n is just the sum of the values for all our items. Now for the over-under method, let's call p our pivot number, and let's let x sub I minus p represent an over if it's positive and an under if it's negative. Now we can write our over-under average formula, just like we had before, only a bit more mathematical. It might seem more complicated than the traditional formula, but it's not. The sigma expression is nothing more than our running total. Now our goal is to show that these two expressions are the same. We'll start with our over-under expression. Recall that the sum of a difference is equal to the difference of the sums, so we can rewrite as follows. Now we'll distribute the 1 over n to each sum. And since the second sum is just adding up p up n times, it's just equal to n times p. The n's cancel, and now we're left with the following. The p's will also cancel. And that brings us right back to our traditional formula for average. So we proved that the two formulas are actually one and the same. Now you can use this method not just knowing how it works, but why it works. I hope you enjoyed this video. If you did, please give it a like and consider subscribing. Also, I'd love to get your feedback in the comments. Thanks for watching and see you soon.